we have a line of code technique, and this is the metrics we use for line of code technique. We have project title, line of code, effort in person month, cost, pages of documentation, errors, defects, and then we have disadvantages, that it's a language dependent method. There is no comparison of hard coded languages like Bol, C, C++ with Visual Basic or the Visual Environment, ID environment. And the current metric is for the current project, the metric is completed after the completion. And there is no direct way to calculate the project cost. There is no indication of complexity. And this is a function point method that we have UFC multiplied by TCF. And UFC is the unadjustable function count, and TCF is the technical complexity factor. So if we have number of inputs, outputs, inquiries, files, interfaces, and we have optimistic, realistic, pessimistic, and we calculate the EC, estimated count, multiplied by the complexity factor. These are the constants provided by function point technique. And this is the formula to calculate TCF 0.65 plus 0.01 multiplied by sigma Fi. Fi is 1 to 14 questions. These are the 14 questions that I discussed in my last video. That does the system require reliable backup and recovery? Are there distributed processing function? Is performance critical? Will the system run in existing heavily utilized operational environment? So these are 14 questions. You need to scale them between 0 to 5. 0 means not applicable and 5 means highly applicable. So after that, the summation of the 14 question is sigma Fi. This is an exercise. We have optimistic, realistic, pessimistic, and we will calculate EC by the formula. We have O plus 4 into R plus P divided by 6. O plus 4 into R plus P divided by 6. We will calculate EC. So this is the exercise. Sigma Fi, we have 50, and it's an average project, so we'll take only the average complexity factor. And productivity of this company is 7 function point, and labor rate is for $4,000 per month, and we'll calculate the cost per function point and the project cost. So we have ORP, we have EC, then we calculate, multiply with the complexity factor, then you have the UFC. And because sigma Fi is 50, so we have TCF 1.15, and we multiply UFC with the TCF. We have sigma Fi is 50, so 1.15 multiplied by UFC, which is 349 approximately. Cost per function point, labor rate divided by productivity, so we have $571, and total project cost per function point multiplied by function point of the new project, and that's the formula to calculate effort. Function point also helped us to calculate effort, total project cost divided by the labor rate. So project cost is 228971 divided by 4000. You have effort in person month. So this is the exercise 2, like the exercise 1. So function point advantages: it's more accurate and efficient than the line of code method. It directly deals with the current project, deals directly with the complexity, and it will help us to calculate cost per function point, project cost, and effort. And it helps us to have a roadmap to calculate time, effort, and team size, which are missing, and size in KLOC or LOC. Very subjective, the disadvantage. while calculating the UFC in terms of optimistic, realistic, pessimistic value for the inputs, output, inquiries, files, interfaces. Very subjective while answering the 14 questions, and it depends on the expertise of the project manager or the system analyst in terms of accuracy. These are the disadvantages. So this is the table I was discussing in my last lecture. We have programming language and average source line of code per function point. For C++ is 64, COBOL 106, Delphi 18, HTML 14, Visual Basic 632, SQL 12, Java 63. So you have SLOC per function point. So whatever the programming language you are using, you will select the source line of code per function point, multiply by function point of the new project, you have the size in SLOC. For example, we have function point. For example, 517. Language is 63. Source line of code, I took 46 because some books use 46. So 517 multiplied by 46, you have 23805 SLOC. So this is calculate the size in SLOC. COCOMO, we have three models. We have basic COCOMO, we have intermediate COCOMO, we have detailed COCOMO or advanced COCOMO. It was introduced in 1981. It is also called COCOMO 81. So basic COCOMO has three versions. Intermediate has three versions. Advanced has three versions. So basic COCOMO is applied at planning phase, and intermediate COCOMO we apply during the analysis and design phases, and detailed COCOMO we apply during the implementation phases to keep track our project. So basic COCOMO has three versions: organic, semi-detached, embedded. So organic is for low complexity for projects, semi-detached is for hybrid projects, intermediate, average complexity, and embedded is for the complex projects and for the embedded projects. So let's go to, so these are the three versions, three modes in each: basic, intermediate, and detailed. I'm covering basic organic mode. Effort formula is 2.4 multiplied by size in KLOC, power 1.05, and time is 2.5 multiplied by effort, power 0.38, and then you can calculate people, effort over time. That's the COCOMO 1 basic. Then we have COCOMO 2. We have which was introduced in 1995-96 by Barry Boehm for object-oriented projects. So we have OP, like UFC. We have number of screens, number of reports, number of components, and for complexity of the project, we have low complexity or simple complexity, average complexity, and high complexity. So like UFC, ORP, so O plus 4 into R plus P divided by 6, you have EC, average count, estimated count, and then you multiply with the type of project, the nature of project. That's the COCOMO 2. So we have NOP, new object point, OP multiplied by 100 minus percentage reuse divided by 100. So this is, we have EC multiplied by the complexity factor. And for productivity, Barry Boehm introduced his own formula and a own table. It's a constant based on experience of the programmers, developers, and based on the maturity of the software company, and scale them between very low to very high. So for very low company, experienced companies, maturity companies, we have 4 NOP per month. For low experience and low maturity, 7 NOP per month. Nominal 13. For high, 25 NOP per month, and for very high, 50 NOP per month. So these are all formulas in COCOMO 2: OP, EC multiplied by complexity factor, NOP, effort, NOP divided by productivity, cost per NOP, labor rate divided by productivity, and project cost per NOP multiplied by NOP of the current project. Time is equal to 3 multiplied by effort, power 0.33 plus 0.2 multiplied by B. B is complexity exponent minus 1.01. So this is formulas. How to calculate B? B value normally varies from 1.1 to 1.424 depending upon novelty of the project, development flexibility, risk management, team cohesion, and process maturity. So we have novelty, how much it is similar to previous projects, what is the precedence of the project, how much the flexibility, and how much the risk management, the team cohesion. So you have to scale them between 1 to 5. 1 means very high, 2 means high, nominals mean 3, 4 low, and very low 5. So for example, for this project we are going to solve the exercise. Precedence is 4. 4 means low. Novelty is low. Development flexibility is very high. So 1. Risk management, no risk analysis, very low. Team cohesion, coordination, communication, nominal 3. Process maturity, nominal 3. So we will add summation of these 5 values, like in sigma fi, or for UFC we have 4 plus 1 5, 5 plus 5 10, 10 plus 3 13, 13 plus 3 16. So summation of 5 factors is 16. Then we divide this 16 by 100 as per the formula to calculate B. Then you have to add 1.01, like TCF 0.65 plus 0.01 multiplied by sigma fi. So 1.01 plus 0.16, that's 1.17, the B value for the exercise we are solving. As you can see, EC is for screen 24, for reports 16, for components 80, and the reuse is 70, and labor rate is, and developer experience, environment maturity are nominal. Labor rate is $4,000 per month. Calculate NOP, effort, project cost, time, and team size. So B is 1.17. So complexity factor, because nominal, and for the screens, reports, components, for number of screens, complexity factor for average project is 2, for reports 5, for components 1. So we have OP value is, after multiplying the EC with the complexity factor, summation of the 3 values is 208. So as you can see in the exercise, we calculate OP, we calculate NOP 62.4, and 70% is the reuse. So we don't need to put 0.07, directly we put 70. And labor rate is 4,000, productivity is 13. So cost per NOP $308, and project cost per NOP multiplied by NOP. Time is 5.3 months after having the effort, which is the 5, and number of people, effort over time, 1 person. Then we have use case point estimation, which is the new line of code method. So we have size in terms of lines is 9530 based on backfiring method. Cost per LOC, labor rate divided by productivity, and so we have 8,000 divided by 620, that $13. So size is 13 multiplied by 9530. So project cost is $12,3890. Then you have Agile Bursting. So that's the new line of code we just covered. We have story points, and company knows how much cost they are spending per sprint. For example, it's 40K, and we have worst case, most likely, and the best case. So we number of sprints for worst case 6, most likely 4, and best case 2. So then you have EC O plus 4 into R plus P divided by 6. So you have the average estimating cost for the agile projects. That's the all cost estimation techniques we covered. Thank you very much. Jazakallah khair.